All right, picking up on example 7, we're going to do the same thing. We're still going to use the same 7 steps. So step 1, let's find out if there's any symmetry. All right, plug in negative x. So we have negative x to the 4th and negative x squared plus 2. And let's simplify. Negative x to the 4th is positive x to the 4th. Negative x squared is positive x squared plus 2. So notice the original is the same as when we plug in negative x. So that was some axis, y-axis symmetry, right? Symmetry with the y-axis. And it's good to know for graphing because, you know, you can kind of copy paste. You don't have to necessarily plug in as many points. Now let's talk about, oh my goodness. Let's talk about our x-intercepts and our y-intercept. So we'll do y-intercept first, which means plug in 0 for x. So we have 0 to the 4th, 0 squared plus 2, you get 0. So there's my y-intercept. Y-intercept is 0. Our x-intercept, you plug in 0 for y. Multiply both sides by x squared plus 2. And take the 4th root, which is still 0. So our x-intercept is going to be at 0. We're going to do some horizontal and vertical asymptotes. We'll start with vertical asymptotes. Remember vertical asymptotes, you want to think about things that cannot happen in your domain. Well, here you know the denominator can't equal 0, but if you were to set this equal to 0, you get x squared equals negative 2. There is no possible x you could plug in here to get a negative 2. Okay, so we actually don't have any restrictions on our domain, so there are no vertical asymptotes. There are no holes because nothing cancels out. Let's look at horizontal asymptotes. Horizontal asymptotes. Notice the degree in the numerator is bigger than the denominator, so we actually have no horizontal asymptotes either. So no vertical, no horizontal. All right. Let's see here. And then we go ahead and let's graph. So we'll graph our x-intercept and y-intercept, which is the same. And we have to pick some points because we really don't know where we're going with this. Let's try 1 and negative 1. So if you plug in 1, you get 1 to the 4th is 1. 1 squared is 1 plus 2 is 3, so 1 1/3. When you plug in negative 1 to the 4th is 1. Negative 1 squared is 1 plus 2 is 3. You actually get 1/3 again. So we have 1 1/3 and negative 1 1/3. So we're actually going to get a parabola here. A parabolic shape. And that's our graph. All right, moving on. So sometimes, okay, in the occasion where the numerator has a bigger degree, if it is bigger by exactly 1, which means the last example, 4 is bigger by 2, so we couldn't use it on here. But in this example, notice how x squared and x, right, this is bigger by 1 degree. Then you have something called a slant asymptote. So if your degree on the numerator is bigger by 1 degree, you can find a slant asymptote. And it's actually a line that you can graph. So how do you find it? Well, you divide. You go ahead and do your division. Now they did long division here. You could have also used synthetic division, right? You could have used a negative 3. You could have wrote out your coefficients 2, negative 5, 1, and you could have used synthetic. Drop it down, multiply, negative 3 times 2 is negative 6, add, multiply, add. And then remember, whatever your degree was, you drop it down a degree. So this is 2x minus 11, and a remainder of 34. So that's your remainder. Now your slant asymptote, you forget about the remainder. So you would actually say y equals 2x minus 11. So this is actually a line that you can graph, right? You can go down to negative 11, there's your y-intercept, and count your slope up 2 over 1, up 2 over 1. So you could have slant asymptotes, and that's what we're talking about here. So here we see our degree is 2, our degree is 1, so it's bigger by exactly 1. So we do have a slant asymptote here. All right, there's no horizontal asymptote, but there is a slant asymptote. So we're going to go ahead and divide. I'm going to use synthetic division. I'm not going to use long division. So see that x minus 2, we use a 2. We pull off our coefficients, so we have 2, negative 5, and 7. And first step is drop it down, and then multiply. 2 times 2 is 4, and add. Multiply, and add. All right, again, you don't care about your remainder. You care about everything else. So we started with x squared. This is going to be y equals. And instead of x squared, we're going to drop it down 1, so it's a 2x and a minus 1. Again, you don't care about your remainder. This would be your slant asymptote. All right, last but not least, so this one says a company is planning to manufacture wheelchairs that are light, fast, and beautiful. The fixed monthly cost will be $500,000, so they are paying that every month regardless. And it will cost $400 for each chair to produce, each chair. So it says write the cost function of producing X wheelchairs. So our cost is going to be $500,000 because we're going to pay that regardless, plus 400 per chair. Oops, that's a 0. 400 per chair. All right, so our cost is the original 500,000 plus 400 per chair. Now this one says they want the average cost, which average is per chair, right? Average is per chair. So you're going to take your cost. So we're going to write our average cost, which means you're going to take your cost, which is 500,000 plus 400x, and you're going to divide that by how many chairs you made. Right? Divide that by how many chairs you made. That'll get you your average cost per chair. And then C, we're going to need a little room for this one. So C says find and interpret the average cost of 1,000, the average cost of 10,000, and the average cost of 100,000. So the average cost of 1,000. So that means plug in 1,000, so 400 times 1,000, add this, add 500,000, and divide by 1,000, and you should get 900. So it does say interpret, right? What does this mean? So this means that the average cost of a wheelchair is $900 a month if you produce 1,000 wheelchairs. So that means average cost is $900 a month if you produce 1,000 wheelchairs. Your average cost for 10,000. Again, we're just going to plug this in. If you plug it into your cost function, you should get 450. So the only thing that's going to change there is the average cost is 450 a month if you produce 10,000 wheelchairs. So I'm not going to write that out every time. As long as you write it once and understand what part's changing, I'm okay with that. Then we have 100,000, and if you plug that in, you should get 405. You should get 405. Again, the average cost is 405 a month if you produce 100,000 wheelchairs. All right, and that's how much your company is going to have to pay to manufacture. All right, the average cost should be about 405. So the more you make, it kind of offsets your manufacturing costs. All right, let's move on to part D. So that was C, sorry. Let's move on to part D. What is the horizontal asymptote for the graph? So horizontal asymptote, here's our function. Notice the degrees are the same. So our horizontal asymptote is y equals 400 over 1, right? Our coefficients. So y equals 400. And what does that mean, right? What does this represent for your company? So this is basically telling you that the cost per wheelchair is going to approach, your manufacturing costs are going to approach 400 as more wheelchairs are produced. So the cost per month should approach $400 as you produce more wheelchairs. All right, that's it for today. Sorry the notes are so long. Bye, guys.